Okay, this is lesson 5.5, and in this lesson we're going to compare lines and parabolas. And we're going to do so by looking at the first and second differences. First differences are just the difference between consecutive y values. In a table of values that are evenly spaced, or that have evenly spaced x values, if the first differences are constant, we have a line. Second difference is where you look at the difference between consecutive first differences. I'm going to show you what this looks like in a table in a minute. And for a quadratic relation, the second differences will be constant. So let's look at a line. We're familiar with lines. If we have the equation 2x minus 4, we know that that's going to have a y-intercept of -4. And it's going to have a slope of 2. So that's a rise of 2 and a run of 1. And we can keep doing that up the table to get our line. And if we forget how to graph like this, that's okay, because we can also make the table. And we can make the table by using the equation. All of our x's, we plug our x's in for x and solve. If we do 2 times -2, we get -4. Subtract 4, we get -8. So -2, -8 will be one of our points. And if we look, that was this point right here. If we plug in -1, we get -2 minus 4 is -6. So -1, -6 will be a point. That's this point. And if we keep going, we got -4, -2, and 0 to complete our graph. Now we did a lot of graphing lines earlier in the course. Now to find the first differences, we're just looking at what's happening between these y's. What's happening as we go from here to here, here to here, there to there, and there to there. These numbers, -8 to 6, -6 to -4, -4 to -2, and -2 to 0, those numbers are going up. They're getting bigger. And they're actually going up by 2. So the first differences, we're going up by 2. And the way you can tell is you take the second one and you subtract the first one. -6 subtract -8. And if you do that, you get 2. If we're comparing these two numbers, -4 subtract -6, we get 2. And if we keep going, we get 2 every time. So because we have the same first difference every time, 2, we have a line. So if you make a table and you compare the first differences, and they're all the same, it's a line. Now, I mean, you can tell it's a line when you graph it. Regardless, if you haven't graphed it, the first differences will tell you if it's a line or not. Let's look at the second example. A car driver brakes and skids through an intersection. The investigating police officer knows that the distance a car skids depends on the speed of the car just before the brakes are applied. Use a chart to determine the car's speed before the skid. Well, here we have speed, and here we have length of the skid. If we compare them, we can find the first differences. All the way down. Looks like they're getting bigger. How much are they getting bigger by? Well, we would subtract. 0.7 subtract 0, that's 0.7. 2.9 subtract 0.7 is 2.2. 6.6 subtract 2.9, 3.7. 11.8 subtract 6.6 is 5.2. 18.5 subtract 11.8, 6.7. And we would do these in our calculator. 26.7 subtract 18.5 would be 8.2. 36.4 subtract 26.7 would be 9.7. 47.6 subtract 36.4 would be 11.2. And the last one would be 12.7. And if we look, are those numbers all the same? The answer is no. So what we know is this is not a line. Let's look at second differences. What's happening from here to here, there to there, and so on as we keep going. Well, let's do a little bit of math. I'll use the calculator this time. 2.2 subtract 0.7 is 1.5. If we do the next one, 3.7 subtract 2.2, we get 1.5 again. In fact, if we check all of these, we get 1.5 every time. So what this will tell us is that our table is a parabola. Now the thing is, it doesn't have to be a whole parabola. It could just be one arm of the parabola. It can be any part of the parabola. It could just be the bottom, the little cup part, or it could be the ends where it's just curving up. As long as it's part of a parabola, it's going to look like the second differences are the same. So let's graph these points. 0, 0. 10 is 0.7, 2.9, 6.6, 11.8, 18.5, 26, 636, 47, and 60. There's our points. And if we connect them, we get this curve. And just as I kind of suspected, it's not a whole parabola. It looks like it's just part of it. The other part of the parabola is probably over here. And it just looks like a big parabola. We just have one part of the parabola. Use the curve to estimate the initial speed of the car if the skid mark is 41 meters long. Well, here's the length of a skid. 41 would hit the graph right here. And if we trace down, we get over 70, below 75, let's say about 72 kilometers per hour. And that's how the police would use a parabola to determine the initial speed of a car. Okay, let's flip it over. The relation h equals negative 5t squared plus 210 describes the path of a rock that falls from the top of a cliff, with h representing the height in meters and t representing the time in seconds. Now the equation has a squared in it, so we know this is going to be a parabola. So what do we expect when we make a table? Well, we'd expect the first differences to be different and the second differences to be the same. So let's find out. We have some t's and we have an equation. Let's use the equation to figure out some heights. Negative 5t squared plus 210. If we do that math, we get 210. If we plug in 1, using a calculator, we would get 205. And if we use 2, we would get 190. If we use 3, well, let's show this one just to make sure we're typing it in right. We get negative button 5 bracket 3 squared plus 210. It's 165. And if we keep going, plug in 4, we should get 130. Plug in 5, we should get 85. And plug in 6, we get 30. All right, these are all of our y's, or all of our heights. So we have times and heights, and now we can look for first differences. We can say, what's happening to our heights? Well, they're going down, so that means the rock's falling. How much are they going down by? The first one's down 5. You can just see it, and if you want to calculate it, you would just do 205 subtract 210. The next one would be down 15, and if you want to calculate it, it'd be 190 minus 205. The next one's down 25, then down 35, then down 45, and the last one's down 55. And if we notice, the first differences, they're not the same. So our graph is not a line. We know it's going to be a parabola, so these differences should be the same. So what's happening here? Well, these numbers are also going down. How much though? Let's try. Negative 15 subtract 5, we get, oops, subtract negative 5. My bad. We get negative 10. Negative 25 subtract negative 15, we get negative 10 again. In fact, we get negative 10 every time. And since these are the same, we have a parabola, which we kind of already knew. So what do the first and second differences tell us about the path of a rock? It's a parabola. All right, let's try to graph this path. We're going to put heights on the y-axis and time on the x's. For times, we can go up by ones. 2, 4, 6, 8, 10. And for heights, we should probably go up by something that gets us pretty high. 210. Let's do 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Uh-oh. Oh, we're okay. 220, 240. And let's graph. 0 gave us 210, so we start all the way up here. And 1 gave us 205. And then we got 190. 3 gave us 165. 4 gave us 130. 5 gave us 85. And 6 gave us 30. So there's the path of our rock. It starts here, and it falls. If we keep going, it looks like it'll cross right there. All right, now we're going to use our table to answer some questions. What's the height of the cliff? It says, hint, look at the y-intercept of the graph. Does that make sense? Well, I think so, because if we're throwing a rock off the top of a cliff, where the time starts is probably the top of the cliff. So we got 210. How long will it take for the rock to reach the bottom of the cliff? At what time does x equal 0? Should say y equals 0. Looks like it's right there. So that's about 6.5. That'd be seconds. And how far from the bottom of the cliff is the rock when half of the time has passed? Well, half of 6.5 would be 3 1/4. So 3 is here, so a little bit more than 3. Let's see. All the way up. Right there. Go across. So that's 160. That'd be 140. That's 150. I don't know, 155 we could call it. If you said 150, I think that's fine too. All right. So that's creating a table, graphing a parabola, and using the graph to answer some questions. And that's it for lesson 5.5. There was a warm-up at the beginning of the lesson in your lessons package. We're not going to include that warm-up, so don't worry about doing that. Just the lesson here. All right, that's it for lesson 5.5. Make sure you try some practice, and that's it for Unit 5, actually. So I'll see you in the next unit, Unit 6, where we look at trigonometry.